Welcome to RGES Algebra 1. This is Lesson 18A, and we are going to finish up our section 7.6, working with E and F, and then doing section 7.7. All right, so 7.6 was dealing with the idea that we were going from a graph to an equation, and I refer to the Lesson 17A tapes if you need a refresher, but we're going from either a graph to an equation or from an equation to a graph. And we're considering both the options y equals, as our general ideas, y equals mx plus b, which is your slope-intercept form, or y minus y1 equals m times x minus x1, which is your point-slope form. So be very familiar with these, and again, go back and review the last lesson, please, on the tape, if you need to remind yourself after vacation here. Now, the last part of 7.6 only introduces one new idea, and that is, what if you have parallel lines or perpendicular lines? Well, parallel lines would be like this and so there's two ideas here in the last part of 7.6. One is dealing with parallel lines. Parallel lines either look like this, they're both going in the same direction, or this, they're both going in the same direction, and the key is that the slopes are equal. By contrast, in perpendicular lines, so here's some perpendicular lines. This would form a right angle. These two lines would be perpendicular to one another. In other words, they come together with a square angle, a 90-degree angle. And the relationship of the slopes here is that the slopes are reciprocal, negative reciprocals. Okay, let me write that in here. So I wrote here the slopes are inverse reciprocals. Okay, now that would mean the same as negative. So let me give you a couple examples of what that would mean. Okay, if the slope of a line is 3/7, then the slope of the parallel line is 3/7. The slope of the perpendicular line, there's my abbreviation for parallel and perpendicular, is the opposite sign, negative, the reciprocal, 7/3. Let me do a couple more. If my slope is negative 2/3 on the line I'm thinking about, then the slope of the parallel line, that's an M, believe it or not, is the same, negative 2/3, and the slope of the perpendicular line is the opposite sign, now positive, and flip the fraction, 3/2. So that's pretty straightforward. Now we're going to use that to solve our problems. Now my first problem, I'm going to be doing some of the even ones for you, and you'll, of course, are assigned the odd ones. My first problem says that I want to write the equation of a line that goes through a point, -3, 8, and is parallel to this equation. Okay, so there's an equation, there's a point. The equation that I want to write is going to be a line that includes the point I see and is parallel to another line. Okay, so the picture would be something like this. I'm given a point, -3, 8, somewhere up here, and the line that I want is going to go through that point. But I'm also given a parallel line. So let's say, well, I don't want to follow this. I just want to illustrate the general idea, okay? It's going to be parallel. The new line I'm looking for, which is I'm going to represent by the red, is going to go through this point and be parallel to that line. So this is the equation right here, is the one I want to write an equation to, but I know that it's parallel to the other one. Okay, so what am I going to do with, going back to the original, what am I going to do with this equation? I'm going to read off the slope, and to do that I'll use my slope-intercept form, y equals mx plus b, and my slope is right here, and there's my slope. Okay, so the slope for the new equation, okay, so the slope of that equation is 0.8, and the slope of my line, because it's parallel, is going to be the same. Okay? Does that make sense? So this is the one I'm working with, and this is the point I'm working with. Now you already know how to write an equation. Now for that you've got point slope, so you need y minus y1 equals m x minus x1. And now I will plug in for the x1, the y1, and the m. So it becomes y, look at your point, minus 8 equals, look at your m, 0.8, x minus, look at your point again and read the x value, x minus a negative 3 or x plus 3. And that's all there is to it. Now, this would be a little challenging to graph with that 0.8 there, but it's very simple to write the equation. Let's look at a few more. Okay, now the y-intercept equals negative 2, and it's parallel to this equation. So I could read off the slope off that equation, and so the slope here is 4, and so the parallel slope, the one or slope of my line, which is parallel, will also be 4. Did I say negative 4? I just meant 4. Okay, so I'm given m here, I'm given b, so I want the slope-intercept form of the equation, y equals mx plus b. I'm going to plug in for m and plug in for b. So it becomes y equals, my m is 4, my b is negative 2, and there's the equation of the line. My next problem says, write an equation of a line that contains the point, negative 4, negative 3, and is parallel to the graph of 2x minus 5y equals 40. Now, I need to use this, let me grab another color here. I need to use this equation to what? To grab or to find a slope. Because I'm given a point and now I need a slope. So I'm going to put this in a different format. I'm going to solve for y so I can read off my slope. Negative 5y, take this 2x to the other side by subtracting. Negative 2x plus 40, divide by negative 5. Negative divided by negative is positive. 2/5 x. Positive divided by negative is negative. 40 divided by 5 is 8. Now I can read off my slope, and the parallel slope is also the same, right? So my m is 2/5. That's an equal sign. So now I have my slope and my point, and if I use my point slope formula, all I have to do is plug in. Y minus y1 equals m times x minus x1, plug in for y, m, and x, and you get go to your point. The y value is -3, so y minus a negative is y plus 3 equals the m is 2/5. X, go to your point. The x value is -4, so x minus a negative is x plus 4. And that's how you do it. Now, if we're going to go to the next example, we're going to talk about perpendicular lines. But we already know if we have the slope, we know how to find the perpendicular. It's the negative reciprocal. So let's do number 46 together. Here we're given a y-intercept of -1 and perpendicular to this equation. We're going to read off the slope. And now my slope that I care about is going to be perpendicular to that value. So my slope is going to be the opposite sign, positive 9/4. Very important. When you're given an equation that's perpendicular, you want to convert to the reciprocal, the negative reciprocal or the inverse reciprocal. Now I'm given a y-intercept and a slope, so I want to use that form, y equals mx plus b, plugging in for m and b, and you get y equals the m is 9/4, the b is -1. Let's do the next one. Now remember that all you're doing with the equation of the perpendicular or parallel line is reading off the slope. The slope here is -2, so the reciprocal slope, the perpendicular slope would be the opposite sign, now not 2/1, but 1/2. We're going to use the point slope form. M x minus x1. So we're going to plug in now for the y value, the m value, and the x value, and we're going to get, of course, we get our y value off the point. The y value is 1. The m is 1/2, and recall this is the converted slope because it's perpendicular, and x minus a negative, so that'd be +6. Now, I think that you could do 50. It's pretty straightforward, just similar. Just all you have to do is be very careful when you're reading off perpendicular slopes that you do make your conversion. Now, 51, 53, and 55 are designed to make you think hard. So I don't want to take away the joy of scratching your head a little and thinking that through. We could go over those in class if you are still confused. But go ahead and work hard on getting those by yourself. Okay, then we are going to do a part 2 on 7.7. So I will meet you at the next tape for that.